My name is Eric Peters. I'm a project manager with the Embedded Vision Alliance, the Edge AI and Vision Alliance, I should say. I will be your track moderator today. Our first speaker this afternoon is Will Florentino. Will is a senior segment marketing manager at the Automotive and Embedded Business Unit of Micron. Will is going to talk to us about some of the challenges at deploying AI at the edge and how Micron is addressing those. Please help me welcome Will Florentino.
Thank you, Eric. All right. So hopefully this works. All right, first session of the day. Thank you very much for joining. So I'm here to tell you that you can't do AI without memory. That's a pretty straightforward sentence. But anyway, what I'd like to do is just talk to you a little bit about where those challenges are relative to implementing any kind of AI model. And then because there's different kinds. And then we'll walk you through some of the features that are in the next generation of memory that might be of interest to you to help you with your next project as well. Right? All right, so you've heard of the memory wall. If you haven't heard of that, that's basically, if you look at how the growth of the models, how these models are growing versus the growth of the memory bandwidth. So here's just an example of a quick chart that says transformer sizes have been growing like 400x, but the memory bandwidth size has only been growing 2x. So just right away, you'll see that after all of the compute has been done, and if you've optimized it, you used to have some compute-bound issues, but now it's all memory-bound, which means you can't, no matter how fast your CPU, your NPU is, you're still stuck to whatever bandwidth that your memory offers you. The second truth is that there's a lot of pre-processing in any AI engine. So if you're doing any kind of video streaming or video object detection or video streaming, you do have to make sure to prepare the information or the pixels and whatnot to work with your neural network or whatever your AI engine is. So here's just an example of just the breadth of, it's a 25x overhead just to run the pre-processing and post-processing as well versus the speed of the neural network. So if you're looking at getting an AI chipset or some SoC that has that thing, you have to figure, memory access, the data still has to be accessed externally to the chip unless you've got all that SRAM built in. The problem with having SRAM built in is they're very expensive. Just like your cell phone, you can get a cell phone. Your Pixel 6 has a 12 gigabyte SRAM, but 256 gigabyte of LP DDR. And the reason for that is SRAM is very expensive on a chipset or in a system. So other than the cost is the flexibility and the scalability as well. So a lot of the chipsets out there, especially the AI chipsets, some of them build in their SRAM inside the chip. The problem is that once the models get bigger or as things scale relative to whatever the use case is, then suddenly you're stuck to having to add more of their AI chipsets to work with. So being able to enable an architecture that supports an external memory is where you'd want to be, and that's where a lot of the use cases are. Especially, we've been partnering with a lot of chipset vendors, AI chipset vendors, that are using or leveraging the external memory for that.